Thanks for joining us. I'm Prudence Ferreira. I'm a senior member of the Carbon Neutral Design Group at BR Plus A Consulting Engineers and lead their Passive House team. And if you haven't been here before, you're in the right place. If you've been here before every single week, thanks for coming back. You're in the right place where we talk about zero energy, zero carbon, electrification, retrofitting our built environment to reduce greenhouse gas emissions. And yes, we may institute a nerd rating scale. All right, so now that we are in year 2, I've found myself making a little space internally to imagine what the accelerator could be and how our community and the relationships that have been warmed and woven here week after week into a colorful tapestry can actually be put into action in a broader context to collectively make change in the world, to build stuff and do stuff. And my co-host, Monty, has been doing some reflecting on his time off too. And he reminded me yesterday of one of my favorite writers, Joseph Campbell. And in his book, Myths to Live By, there's a quote I wanted to share with you guys. He says, "A curious characteristic of our unformed species that we live and model our lives through acts of make-believe." So I'd like to make a toast to that bridge of make-believe that connects vision to mindful action. It's imagination. It's what allows us to come together around a shared vision, and from that, we can take collective action. So please unmute yourselves and help me open this episode with the toasts to imagination.
Cheers.
Cheers.
Imagination.
Cheers.
Yes.
Cheers. Cheers.
Cheers.
Cheers.
All right. So mute yourselves and settle in for another great episode. Our featured guest is In Cho, who's going to share an incredible and innovative Passive House retrofit project with us. But first, over to my co-host, Monty Paulson, who's going to share some poignant thoughts about Passive House Hero's journey.
Hi, everybody. It's so nice to see you all. As most of you know, I've had a great 2 months off to kind of think a little deeply about me and Passive House and what I'm doing, all these things. And 2 interesting things kept coming back to me. I got really curious about what the process was like for people who are just starting. For those of us who've done it for 10 or 12 years, it starts to be just like work. And I thought a lot about what it was like to go through one's first Passive House process. And I'm also really grateful to my 13-year-old Galen, who drove me to spend a lot of time rewatching all the Star Wars movies over this break as well. And during the one, thinking about the other, I came up with this just little document I want to share with you here. Can you all see the screen there? I realized that, yeah, for many of us, Passive House is a bit of an adventure, like Joseph Campbell's hero journey. That this call to adventure begins when we get invited to do our first Passive House project, or we start to pitch our first Passive House project. And much like a hero's journey, we immediately reject. We refuse the call. It's too expensive. It can't be done. It's too unrealistic. There's all these reasons why it can't happen. But then as we continue down the journey, many of us find ourselves crossing that critical threshold where we begin to realize it's not really about Passive House at all. It's part of a larger process of moving from architecture of the fossil fuel age to architecture of the Anthropocene. We're crossing into this new realm, this new era. For some of us, that's accompanied by passing a CPhD exam. And then we start through the trials and tribulations. Often these are presented by code officials or by suppliers or others who just can't understand what we're going to do and will get in the way of us trying to simple solutions that will improve performance. Some of us hit a point of despair and hopelessness. This often comes together with the design stage review or pre-certification and change orders, where the team's trying to water down the performance of the building at the same time your certifier is trying to tell you it has to get higher performance. We then hit that critical stage of death and rebirth, where the client wants to drop certification. We'll just tell them it's a Passive House. We don't have to actually certify. Why bother? We start our path back through that revelation that it's actually easier to do a very low energy building than a mid energy building. And by pushing the target lower than the minimum requirement generally makes the project easier, not more difficult. There is, of course, that period of atonement, much like confession. In this case, it often comes in the form of confession to a building certifier. This is what I tried to do. It didn't work. Here's what we're going to try. How can we work this out? And the road back begins when that design stage review or pre-certification is issued. We see resurrection within sight when we finally pass a blower door test. And ultimately, we're able to return to our teams with new gifts in the form of a building certification plaque. What I want to say that is, if you have experienced anything like this on your first Passive House project, you're right where you're supposed to be. We all went through this. Our first projects were all really hard. They were challenging. They felt like hero's journeys. And you should applaud yourself and feel comfortable if any of this makes sense. The reality, as Prudence and so many others here can tell you, is there's your first Passive House and then there's all the rest. It gets far, far simpler the second time around. It gets wildly simpler the third, fourth, fifth, sixth time around. And by the time you do a few million square feet, it just seems like the only way to do anything. So I just want to kind of welcome you all, urge you to embrace the hardship, embrace the difficulty, see the humor in it, see that what you're doing matters, and give each other a hug. Thanks.
Thanks, Monty.
Thanks, Monty. Thanks, Prudence. So we're going to go into small groups now. So let me set that up, and it'll be 5 minutes. So rapid fire introductions, please. And make sure you get around and everyone gets a chance to say hello. And we'll see you back in a few minutes.
So our featured guest tonight, In Cho, well, her journey to Passive House started with healing injured animals as a teenager and aspirations to become a veterinarian living abroad. Somehow, this goal organically led her to her present life, now with a Master of Architecture from Columbia, licenses in multiple states, and being very well known as a Passive House designer. Zach, please mute yourself. I can hear you typing. As co-founder of ChoShields Studio, In has shaped their multidisciplinary practice to be really dedicated to social and environmental sustainability. And her strong desire to connect all ways of life has informed her architectural work in a wide range of styles: commercial, residential, renovations, new construction. And her multidisciplinary approach has also led her to engaging in public policy, as well as educating fellow industry professionals and the younger generation on sustainability in our built environment. For those of you who have been with us for a while, you may remember videos of children teaching about Passive House principles. That was In's work. So In's approach to design brings to life healthy and poetic connections in a cultural fabric that's socially transformative, ecologically productive, and inspiringly beautiful. We're so fortunate to have you with us to talk about your project, and thank you.
Really, really great to be here with all of you. Should I share my screen and start the process?
Yes,
okay,
please
great.
do.
Let me do this. And let me know that we're sharing the right screen. All right, so well, before I begin, Monty, I just want to say thank you so much for your Joseph Campbell reference to the hero's journey, which definitely so accurately resonates with the first time Passive House experience, and even potentially the second and third, but it definitely does get better and easier, as you rightly said. And also, just to, before I get started, I'd also really like to thank Passive House Accelerator for all the great work that you guys have all been doing, proliferating Passive House ideas, and really strengthening our community and throughout this process. And it's really, really exciting to see our community expanding through this shared knowledge, and it just seems to be getting greater and greater and bigger. So thank you, Passive House Accelerator, for all your great work. And now I'd like to share with you one of our Passive House journeys, which started here in Gramercy Park, Manhattan, where on East 20th Street, there was a brick shell building with wood joists. It was a two-family duplex over duplex. And this project started with two conflicting parameters between the existing condition of the building and what our clients desire from it. The existing building had dark interiors, had very small exterior windows, low ceiling heights and with spaces that were really closed off from each other, as well as having incredibly stale interior air throughout the entire building. Furthermore, it also had a great amount of structural deficiencies in both the party walls as well as in the foundations. And the building footprint was quite small at 19 feet wide. So those were the existing building conditions. As far as what our clients desired from this building, first, I'd like for you to meet them. This is Sudha and Anil Sahai. What they desired for this project to embody was the essence of their love for the ocean with its fresh sea air, the calm sound of the waves, and it's just vast openness. They love this feeling. And they also wanted the project to embody their love for an abundance of sunlight and just all natural elements in general. Thus, our clients wanted this whole space to focus on sunlight, fresh air, calm sounds, open space, and natural elements. And even more, they also wished for a lot more program than what this particular small footprint could accommodate graciously. And at the same time, while they were wishing this, we were trying to meet all of their desires and within the context of what originally started out as a simple cosmetic interior renovation only. But as fate would have it, just as we were finishing the bid set for the following morning, Sudha and Anil called us and they asked us to increase the scope of work. And this changed everything. This led to a 1.5-story vertical addition, new increased floor-to-floor heights, and a full rear horizontal extension. Now, while it would have been easier for us to continue with conventional building strategies, this far into the project, knowing that now we were more actively engaged to design the building envelope, and to address issues of building science, such as preventing condensation and mold, and knowing what our clients desired the most, all of this led us to consider the significant benefits of passive house design. And thankfully, to the open-mindedness and faith of our clients, Sudha and Anil, and with the support of the Passive House Institute, Passive House Academy, 475, and rest of the entire Passive House community, we began our journey into this Passive House retrofit. Among the 5 principles of Passive House, 3 of these principles were particularly challenging for our project. And this required a lot of thinking outside the box in order to meet the requirements of the Passive House benefit standards. The first of these was the passive solar optimization. Due to our 2 very tall neighbors to the south of us, we had only 1 hour of direct winter sunlight to rely on for our passive solar heat gain. And this was not sufficient to meet the full passive house requirements, such as for space heating demand, which contributed to directing us in certifying under the NFIT component certification. And that gave us more leeway for situations that we could not readily control, such as this. And it also did not meet our client's desire for abundant sunlight. So all of this placed a lot more burden on the building envelope's thermal performance to compensate for the lack of solar heat gain during the wintertime. And so through a lot of research in our studio to address this challenge, we developed a mosaic of different building materials, different building assemblies, which were poured in place concrete masonry units, brick, structural steel, wood and light gauge metal framing, and exterior rain screen. Each had its own unique characteristics, which we had to carefully consider in order to optimize the thermal performance of each of these assemblies. The colors here represent 7 different exterior wall types that made up the building mosaic so that we could maximize the thermal value for literally every square inch of the building envelope. The second and third passive house principles that were also of particular challenge for us were thermal insulation and thermal bridge-free design. And this occurred hand in hand. But before we could address this, we first had to structurally remediate the existing building and prepare for the new extension. And we did this with poured in place concrete for the foundation, new concrete masonry units to reinforce the structurally deficient party walls, poured in place concrete for the party wall transition curve to receive the new extension of the structural steel and light gauge metal framing. So for the thermal insulation performance of the new vertical and horizontal extensions, our selection of the construction types was based on maximizing the insulative value of the wall assembly, balanced with structural and fire code requirements. So for the front and rear extensions, the building code for this project allowed us to take advantage of the higher thermal performance of wood framing. And for the rear of our horizontal extensions, structurally, we used a full height steel moment frame, and the wood was only used for the wall infills. And for our party wall extensions, which had to be completely non-combustible by code, rather than continuing up with masonry, we chose structural steel and light gauge metal framing in order to achieve the same thermal performance as masonry, but gaining an extra foot of width in our narrow interior space of the 19 feet wide building in this Manhattan townhouse. So, and now for the third passive house principle of thermal bridge-free design, which needed to be considered at the transition from the existing masonry party wall with its now new poured in place concrete curb that is to receive the new metal frame extension. And we had to, in this case, isolate this change in construction types with two different thermal break materials. And we can see these two types more clearly with a closer look. For the structural steel bearing points, we used a high strength Fabrica thermal break material. And for our light gauge metal framing, we were able to use choose a different material, the foam glass product, which had better thermal performance. But this particular product required using a steel tube to transform the point load of the metal studs into a uniformly spread load that the foam glass material required. And to get the full thermal performance of our new party wall extension, we used a 4-inch thick continuous mineral wool, rock wool, before it used to be called Roxol, insulation throughout. And to eliminate the thermal bridging of the fastening system for the insulation finish cladding, we chose a fiberglass-based clip system, Cascadia clips, to isolate the metal Z-girt from the metal studs. And here is a thermal modeling of an exterior wall that uses a conventional clip system, where we can see the result of the heat flowing out of the building through the fasteners. And here, with the fiberglass clip system, the conduction of heat is impeded. Here's a thermal image of a test wall built both ways, where we can see the reduced heat loss on the left side compared to the conventional clip system on the right. So with all of these strategies in place, when we compared it to the New York State average household energy use, in addition to meeting the passive house benefit target, we also achieved a 77% reduction in energy use. And here are some of the building results. The front of the building, where we enlarged and reconfigured all the windows in order to address the increased floor-to-floor height, as well as bringing in more daylight, along with the vertical addition that you can see in gray. And the first floor interior, where we created a much more open flow and let more light in through the larger clear wall high performance triple glazed windows. And similar looking the other way. And one of the bathrooms, where we used materials that were reminiscent of the ocean sand and wood, along with the invisible features of the balanced ventilation system that provides the freshest filtered air, replacing the formal stale air quality in the building throughout. And the former top floor with low ceiling height and closed-off spaces, with increased floor height now throughout the building. And again, bringing in more sunlight and openness that Sudha and Anil were desiring, inspired by nature's characteristics. And the former cellar with similar strategies. And finally, the rear facade. Another opportunity where we were able to enlarge the glazing in order to bring in more light and a sense of openness by using the high performance triple glazed windows in order to ensure optimal thermal performance. And so thanks to Sudha's and Anil's trust and deep patience, we were able to persevere in solving these very complex building issues. And now, while the usual goals in construction is typically to simplify the building process as much as possible, in this case, due to the kind of complexity that we were facing, we found that a mosaic of construction types is what gave us the best result. And I'd like to share with you just quickly a segment of Sudha, our client, speaking about her experience so far living in this passive townhouse that was created by 475 Performance Building Supply.
In a nutshell, I think living in a passive house is having the ultimate homeliness that you want in a home, and the best metaphor for it is being in your mother's womb. You're insulated, you're protected, but as yet you have everything you need. You have fresh air, you're surrounded by the perfect temperature, you're living in the perfect temperature, and you're coddled.
It's been a true privilege and seriously rewarding to hear the satisfaction of Sudha's experience living in this passive house. And knowing the incredible benefits of passive house, we now apply and reference passive house as our North Star and apply it everywhere, even no matter what the context, whether it's from the upstate New York Gold Creamer structure that we designed to an urban masonry construction additions, you name it, it gets applied. And not only in building designs, but also to spread the word and empower everyone to learn the benefits of passive house. We are extending beyond our professional community, as Prudence has mentioned, and teaching in all levels of schools. So from last year, teaching in high schools to elementary schools, even remotely during our pandemic, and really getting to see how they come up with creative ideas, from dance forms to kindergartners, drawings on exploring installation, as well as a third grader talking about energy recovery ventilation systems. And you just name it in so many other creative ways: Lego sets, models, dance movements, and drawings. And just having fun, enjoying exploring passive house ideas, even to creating a music video remotely during the pandemic. This really shows that the resiliency of our community to learn and express passive house ideas truly really shows us that no matter what the context, passive house really is for everyone. And just to help in this endeavor, I'd like to further share with you a little bit of what we learned from some of our passive house journeys. First one, what we've learned is to really have good timing of integrating passive house as part of the first design decision, which we found to be the best way forward, much less headache, unlike how we approached this project, not because of choice, but that's part of the big lesson we learned. The second is also having a good contractor, which I think we're all aware of. And this doesn't necessarily mean that they're experienced in passive house, but that they are truly open and wanting to do good work and doing the right thing. So of course, if they're experienced in passive house, so much the better. But at the end of the day, just someone who's very open-minded and willing to do it and having the desire to do it. The third lesson that we found was, particularly if you are working on an infill townhouse project with shared party walls, such as this project, being good neighbors is critical to projects going smoothly. Often we depend on them for access to build from their side of the property, or in general, we make lots of noises on our side and many factors that would impact our neighbors' lives, which could potentially get them annoyed to the point where they call the Department of Buildings and put in a complaint that shuts the job down for further investigation and literally delays the project for months, which we have experienced. Thus, we found out that having a really, really good communication and understanding with the neighbors goes a long way to making the whole construction process so much easier all around. The fourth lesson is, and this is just a technical one, but to emphasize in when we introduce thermal breaks, that they really maintain structural integrity to the construction assembly, as well as meeting any fire codes. To always ask how a particular thermal break material is behaving in its structural performance and what are the parameters it requires for optimal performance by checking in with the manufacturer specifications, their technical representatives, and confirming it with engineers from their side as well as our side. This is probably one of the trickiest that we find in detailing is thermal breaks and creating a thermal bridge-free construction. And fifth is to stay optimistic and have faith. Never give up, no matter how challenging the work scope seems to be. There are always solutions. As long as there is a will, there's always a way. And I have many. The sixth is that something that is intrinsic in architecture already, thus should not be such a far stretch, that is to have deep perseverance and patience, even more with Passive House, which truly puts this to the test. And the last one is assume that there will always be problems to solve, which is one of the main aspects of architecture to start with. Thus, no surprise there, just another day of good old-fashioned architectural problem solving. And with all of these pieces of the pie and just a little extra gray hair, we get to experience all the benefits of Passive House. And if this is your first Passive House project, as Monty has said, the next one gets a lot better, easier, and definitely promise that we'll all be so glad that we did it. And that's it. Thank you very much.
Thank you so much. And those were fantastic lessons learned and such a great presentation. You present so clearly and concisely and just great information. I'm sure we have lots of questions. I've seen them coming in. So we're going to take big picture questions for the next 10 or so minutes. And then after that, we'll break into small groups again in breakout rooms and then come back for all group questions. And we would love it if you are able to stay with us into the after hour and hang out and experience the lovely nerdiness that this community is comprised of.
Okay.
Tonight we're going to have Mary doing questions. So
thank goodness.
Yeah.
Okay.
Yeah. So she will concierge the questions.
Thank you.
And then the folks that have the questions will come on and ask them.
Perfect.
Okay, so we're going to start with Ingrid. Ingrid, you had so many questions. So if you could limit yourself to, let's say, 2 for now, and then we could get into more in the after hours. That'd be great.
Absolutely. Very, very well done presentation. I enjoyed that thoroughly. Thank you very much. I guess my 2 questions have to do with time. And my first question is, how long did it take before you built anything, the conversations and the design and all of that? About how many months was that? And then from permit to move in, what would you say is, how long did it take?
So let's see. Yeah, this was quite a challenging, arduous process. As I mentioned, we initially started this project as a non-passive house project. And so we had spent the first 6 months designing for a simple interior renovation. So I guess that part doesn't count. But from the moment that we started with the new expansion of the building, both vertically and horizontally, I think the entire design plus the filings, approval set, all that took about under a year. And then we put it into bid, and we literally were working simultaneously from, and this project, I recommend no one to do the process that we took. We only did it because we had no choice. But literally in the middle of this project, as we were doing the approval set, the construction document set, and the bid set all together, we were also implementing passive house strategies from fresh. So there was a lot of, I really literally got quite a bit of gray hair because of this process. But I think that whole thing took about a year and a half. And then from permit to move in, that took, and this again, lessons learned, we actually had a great deal of challenge with both of our neighbors, the east and west. So the minute that we, they were, I don't know how many of you are in New York City, but by code and by law, we are required to inform the neighbors of the beginning of work. And this is a typical thing that we have to do by code. And even with the proper notifications that were handled, both of the neighbors gave a lot of challenges to the progress of the project, including having had the project shut down more than once. And for no other reason. But at the end of the day, it really is, it's a very arduous process for everyone. So it's all understandable, but that also delayed the job for quite a while. So at the end of the day, I think total construction time ended up taking about 2 years total. And it probably could have been less by, I'd say, 6 months if it weren't for the fact that the job actually got interrupted for various reasons that was outside the control of the project itself.
Thanks, Ann.
Wow. Okay, Susan in Toronto, you're up next.
Oh, thank you. And that was really lovely. My question was just about the difference between the retrofit and the new build for Passive House. And were there any limitations to what you can consider a retrofit? Because by the end of it, I was just wondering what was still existing in that building.
That's a very good observation. Yes, and we used to actually make the same comment ourselves. We said the only thing that was left was just the brick party walls, and even the front facade got so reconfigured that it was kind of, what is that? I don't know the expression about an animal in a wolf's skin, or I can't remember the expression. But yeah, it really was. It felt like almost that it could be. And the irony of it all was that because of the fact that we were working with the existing party walls that were structurally deficient, and that we didn't want to do underpinning. So structurally, we had to do what's called an eccentric Coford slab. I mean, it really created many more layers of complexity. In so many ways, it might have been just easier just to demolish everything. But then, of course, there are other code considerations, filing stages, and everything else. So all to say that it probably would have been a lot easier as a new construction project. But so we always tell ourselves that, by doing this project, any other retrofit projects that we've been doing since, doing Passive House has been so much easier. Like it's quite phenomenal. Yeah.
I think you call that a cakewalk then, right?
Well, yeah, relatively speaking, yes. Yeah, definitely. Yeah, this one definitely pushed us to the test.
Thank you so much. It was beautiful present.
Okay, up next is Jeff. You had questions about what got put in.
Yeah, thank you very much, Mary. And that was a well-presented project, and really appreciate being able to see it. I'm involved in building in the city, so I know the challenges for sure that you're talking about. But I would expect on a building that's whatever, 5 stories, I don't know, you needed to put in an elevator and a sprinkler system.
We had sprinkler, yes. Elevator, no, because it was 4 stories plus a cellar. So if it were, so it's 5 stories if you include cellar, but by code, it's 5 stories above grade. So therefore, there was no elevator. But well, we did do sprinkler.
5 stories does require an elevator.
Yes, exactly. So, exactly.
And
so we had a 4-story.
So sprinklers and any new stairs that you needed to put in, whole new egress.
Yeah. So yes, yeah, yep. It was all fireproof, 2-hour fire rated. It was a 2-family. It was an originally duplex over duplex, and then it became a 2-family duplex over triplex.
Thank you very much.
Great. And then Patricia, you had a question that I think got answered in the chat, but if you want to, if you want it elaborated on, come on. Patricia? Well, she had a question about why not wood framing, which Louisa said, you're not allowed to use that by code in New York City. Is that correct?
Yes, for the most part, that's absolutely correct. And there are some exceptions, which is what we took advantage of. For example, the code allows exceptions for 1 and 2 families that, for certain areas. So our front and rear, because it had more than 30-foot distance to the neighbors, we were able to use some wood frames for there. And based on the fact that we were also able to use a 1968 code rather than the current 2014. So if we were using the 2014 code, we would have to do it all non-combustible. So that front and rear where you saw the wood infills, which were not structural, that would not have been able to happen if we used the 2014 code. But since this building was built, I believe 1912 or so, we were able to refer to the 68 code and was able to have that exception in this project.
Wow, great research that you were doing. Okay, JR in Boston. I think your question also got answered, but if you want to come on. JR? He was just asking where you got the foam glass from.
That is the product. I believe it's called foam glass. So if you just Google foam, FOAM, glass, you'll find it, and it's GLAS.
Right.
Is that the same as Aeroglass or different?
I'm not sure. Good question.
Okay, so next up is Stephen Glickman.
Sorry, just had a cookie. My question was, were there exterior ordinances that you had to comply with in terms of design review? And I think the following question addresses it more specifically with someone who's more familiar with the area. So I guess, was there a design review of the exterior?
Oh, no, it did not, because this was not a landmark building. We were about maybe a block away from the landmark district, but yeah, no.
Okay, great. Well, that answers the next question, which was whether it was in a landmark district. So that answer would be no. And then Patrick Walmsley, you had another question about the gravel. But did you just get it answered? Yeah, you did.
I don't think it's the same as aerogel. I was just looking it up.
I don't think so. Aerogel, no, it's not the same as aerogel. We did use aerogel in our project, though. In a very challenging, tiny little spot.
How much did the whole, I think probably next in that queue, how much was the whole project cost-wise? It was very impressive.
It started out as a rough square footage. We were aiming for $300 a square foot. And mainly due to, and at the end, we didn't have the final number. There was actually, it was a very complex process. We actually had to switch contractors 2/3 into the project. And then, there was a different relationship with the client and the contractor and how the whole monetary aspect was handled. So I don't know the final number, but I believe that due to the structural complications of the project, which was truly the biggest factor. It wasn't the passive house, it was the structural remediation of it. And I think it came out to about $375, $400 a square foot. And the increase was more due to structural complexities more than anything else.
Thank God that was in New York City. That's all I can say. Very cool project.
Okay, Bruce, you had a question. Are you around? Bruce Nagy? or Naji. I apologize if I'm pronouncing.
Sorry, can you hear me now?
Yes.
Okay. Yeah, I just wanted to ask about mechanical systems. I'm sure they're quite simple and quite common. What
Very
was the,
straightforward. The ventilation was, Zender, and the heating and cooling was the air source heat pump of Mitsubishi split units.
and what is that stuff was new, right?
Yes, yes,
Yeah.
everything was
But
new.
what was in there before?
There was a standard, actually, in terms of cooling, there wasn't any, I believe there were radiators, so boilers, heating systems.
Yeah, okay. No
Radiators.
idea on changing costs for operation?
Well, the building actually wasn't occupied when the owners bought it.
Okay.
So it hadn't been operating physically, live for over a year, but the existing heating system was a gas boiler.
I just want to say I love the kids. Fantastic with children showing how to do insulation.
They're amazing. Yeah, it's amazing how they really, I mean, we're literally talking from kindergartners to college students, and they all understand this principle, in its basic form. So it really, I mean, they really show us that this idea is very common sense based. Yes. And that it really can be embraced by everyone. So they give us a lot of hope.
Yes, I'd like to take those children to some of the municipal policy planners that I teach.
Oh, you know what? Actually, we should, because right now I'm also teaching this week the one of the high schools in Bed-Stuy in New York, Boys and Girls High School, and we're also continuing with the elementary school that we taught last year, and they're going to be involved in doing more projects of this kind. And we're always trying to get the
video. Shoot video of it. Shoot video of it and send me the video.
Sure. Yeah, send me an email. I don't know how to get in touch with you, but let's.
I will, because I want to do a story on your project anyway.
Okay, great. Well, so yeah, I don't have if you have my contact info, please, feel free to send me an email.
I'll put myself in there. I write for plumbing engineer.
Just calling it out. Zach just posted in the chat a link
great. Thank you.
ChoShields.com/education arts. So there are a bunch of video clips in there as an appetizer.
Okay, great. Thanks, In. Good job.
Yeah, and we're doing a lot more with the kids as we speak, and hopefully there'll be more stuff for the North American Passive House Conference with new creative endeavors. Perfect. It's been really fun. Yeah.
Okay, great. Tom Phillips, now you're up next.
Oh, hi. Just a quick nerd question about show me the PHING data. I'm sure you did the modeling of indoor environmental quality things and noise, temperature, thermal comfort, and so on. Are you going to do any verification of that in terms of monitoring?
Thank you so much for mentioning that, because it's something that we have been wanting to do so badly. For this project, we were not able to because of different tendencies, and there are various factors, but we're really, really looking forward to doing it in our next Passive House project that we're currently working on in Greenpoint. So that's something that we're really looking forward to doing. Thank you for mentioning it, because that really is a very important aspect to really seeing that it works. So very important factor. Thank you.
Well, thanks for sharing that great project and hanging in there for so long.
Thank you.
So I'm just gonna interject my own question about that, since you just mentioned, so you're gonna be monitoring a project that you're working on in Greenpoint?
Yes, it's in design phase, but when it's built, that is the hope. And so we are in the process of discussing the possibilities. Yes.
Great. Okay, Pablo, staying up late in Barcelona, has a question for you.
Hello, it's regarding the frames for the windows. Why did you choose, I guess it was wooden frames, right?
They were aluminum clad wood frame.
Okay, so and what's the most important feature to choose this kind of frames?
So the most important feature is obvious. They're high performance. They're triple glazed. Typically, they have extremely high levels of air tightness. You know, these were certified passive house windows to guarantee that they really will perform to what they're supposed to. Their U value is 0.15, so that's the passive house standard for high performance windows. And we also picked this particular one at the time because the cost on them were very good. And it's, in fact, it was the reasonable cost of these high performance windows that actually allowed us to pursue passive house, because often back then, you know, there weren't that many passive house certified windows, high performance triple glazed windows that were very cost efficient. And so that was always a deterrent factor. But at the time for this particular company, Clearwall, their price was same as a double glazed window. And because of that, it really kind of started, it created the impetus for us being able to do passive house. As you can see, we have many windows too. So you just have to look for high performance, you know, make sure that it has, if it's an aluminum metal frame, make sure that it has a thermal break. If it's wood or UPVC, the thermal break is not required because the material intrinsically is low conducting in heat. So that's all good, and it has air tightness. And then there's different solar heat gain coefficients and all that you can find in the tables for a passive house guy.
Okay, thank you.
You're welcome.
And okay, now I'm gonna just interject a question for you, Pablo. Aren't there a lot of, in Spain, there's a lot of companies that are making passive house quality windows, yes? Do you know?
Yes, well, in fact, we are French producers, but with a different kind of frame. This is why I focus my question on the frames. Obviously, when you are looking for passive house windows, you can select double, triple glazing with different types of frames, but you select the window, not only the frame and also the glass.
Certainly for the frame, you want the thermal break. You know, that's the big thing. And any kind of gasketing to be also low conductive in terms of the heat transfer.
You will have a new choice in the coming months for passive house frames. Yeah, you will see.
Oh, well, if you're also detailing framing, detailing the frame of the windows, one of the things that's really important that we've had to kind of compensate with, because sometimes this detail doesn't exist in the frame itself, at the sill of the window frame, you know, because we typically want to have the insulation outboard of the, you know, the window sill, the frame at the sill, and we want it to overlap. And to do that, we need the kind of the rain drip to be kind of, let's say, 2 inches above the edge of the bottom of the frame, so that we deal with the rain drip. And often we found that some window manufacturers have this feature, others don't. When they don't, we're able to compensate in our detailing, but ideally it would be better if the window frame had that particular detail as an integral part of the frame.
One last question, which is the width of the frame?
The depth or the width? The depth is, I think it was about 4 inches, but I'm not, somewhere around there.
Okay.
Going from outside to inside, right? That's what you're talking about. Yeah.
Okay, I think, Zach, did you want to?
Yes. Oh, good. It's all right. I will do my little bit here. Thank you. I'm totally engaged in these questions. This is so wonderful, Anne. Thank you. So I'm going to take a moment to thank our sponsors. Everything we do at the Accelerator happens because of the support of these fine organizations. So please consider them in your projects. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A Consulting Engineers, Brennan Installation and Airtightness, Inotech Windows and Doors, and US Engineered Wood T-Stud. And as I mentioned earlier, thank you to 475 High Performance Building Supply for being our sponsor of the week this week.